All right. We got to dive in, peeps. So, 5-5. As you guys should know, I like food. Sometimes more than I probably should, but I like food a lot. So, I decide that I'm going to be nice. And I'm going to run out to a taco truck and grab a couple tacos and a drink for a lunch special. But I, before I head out, ask around the team. And I say, hey, anyone need any tacos? And of course, Mrs. Cullen and Mrs. Goldring are like, yeah, we'd love some tacos. Go ahead and pick us up some lunches. So I head out to the taco truck, and I buy myself, Mrs. Cullinan, and Mrs. Goldring a taco lunch special. Now, we know that in a taco lunch special, you get 2 tacos and a drink. So what we want to figure out is if I buy 3 of those, how many total tacos and drinks am I going to end up with? What do you think? And before I start messing with this, I need to clone this before I forget, because otherwise there will not, we'll clone it later. So, as promised, we now have your cards. So that I can, at random, get you guys to participate. So, by the way, for those of you playing at home or here, it is the 12th. I, if I was you, would date everything so you can keep in order. So, our first victim, Miss Suddendorf. How, when you think about 3 combo meals, how are you thinking about this problem to figure out how many total tacos and drinks I bring back? What do you mean? What do I add? So I have 3 people, and each combo meal comes with 2 tacos. So you say we're going to add people and tacos together? I'm going to end up with some people tacos? I think that's a bad idea. So this goes back to like terms. Be careful, because we're only ever allowed to add or subtract with values that are like terms. Hey, Abby, you with me? You got notes? Because I don't see notes on them. Okay. Thanks. No, this is not on the notes. She was writing and not on her notes, so. Andrew, what do you think?
Well, since it is a combo, I would add the 2 tacos and the drink.
So then I would get 3 taco drinks?
Well,
can I add tacos and drinks?
Like, add it as a combo.
So what I have right here is the whole add it as a combo, but can I add tacos with drinks? Are they could I talk about a taco drink? No, that sounds really gross. So, Jaheim, can you think of an idea?
I'd say, how much tacos and drinks you get until for each drink?
Yeah, so I get 2, Cullinan gets 2, and Goldring gets 2 tacos. Then I get a drink, Cullinan gets a drink, and Goldring gets a drink for drinks. So we would look at tacos as one thing and drinks as one thing. Justin?
So if you're getting 3 meals and each meal consists of 2 of each thing, you multiply how many meals you're getting with the quantity.
So I'm going to take the fact that I know I'm getting 3 meals, and I know each meal has 2 tacos. So if I get 3 meals and they each have 2 tacos, how many total tacos am I bringing back, Abby?
6 tacos.
6 tacos. How many total drinks if I get 3 meals and each one comes with 1 drink? How many drinks? 3. And I get, wherever delete is, sure, cut works. Oh, there's delete. 6 tacos and 3 drinks. This is what we call our distributive property, and we always show it with these arrows distributing from the number in front of my parentheses to each individually, each portion inside my parentheses. So today, talking about our operations with rational numbers, a lot of what we will do is dealing with the distributive property. So apparently my file did not save correctly. But our learning target is really that we know how to work with rational values, and that's why I kept asking about like terms. We can't add non-like terms, so you have to be careful. So we have this expression here. -5 times 3 plus 2 plus -4. And there are really 2 ways that we can solve this. One way is following PEMDAS. right? We'd do parentheses. There are no exponents. Then we would multiply. There is no division. And then we would add or subtract. The other way is using the distributive property, which is what I want to show you guys. So right over here, under distributive property, I want you to draw arrows from A to B and A to C. Then I want you to draw arrows from A to B and A to C. But especially if you have colors, that minus in between the B and the C becomes the minus between the A times B and the A times C. So this minus that was right here carries over to be this minus right there.
But there's a plus sign.
Yeah, so over here there's a plus sign. But realize that whatever the A is, that whole value multiplies by both of them. So I am going to, and if you don't love colors, I'm probably going to put more colors to this than you ever care to look at.
I like colors.
But I'm going to use a bunch of colors here. I'm going to show my -5 multiplies by both of these. Now, I agree. I could do this addition first. I'm not to show you how this works. So you don't have to take this process. But let's say, what if 2 was x? And I could not combine these. This is how the process works. So I'm going to do each of those. The first green arrow gives me -5 times 3. Then my plus just comes down as a plus. Then my blue arrow gives me -5 times 2. Please make sure we're getting all this written down. And then I have plus my -4. Any questions on what I've done so far? I took my -5 and I multiplied to both of the terms inside the parentheses. Yeah.
What would you do if 2 is x?
Then it would just be -5 times x. Because if these were not like terms, we would have to distribute. Here, I don't have to distribute. I could combine these. But because I have the option, we want to look at what would happen if we distribute. Because we just want to start practicing this. So, -5 times 3 becomes -15. And because it's negative, I'm going to go ahead and nestle it in some parentheses. I still use my plus. -5 times 2 becomes -10. And then I still have my plus -4. Do I have addition?
Yes.
Do I have same signs or different signs? Yes. Yes, I have the same sign. So, same sign, I know that I'm going to save the sign. I'm trying to find black. So we know my answer will be negative because if I have a debt and I add more debt and then I add even more debt, I have a lot of debt. So I owed 15, now I owe another 10 on top of that. Takes me 25. Then another 4 on top of that takes me 29. But I am negative for that whole thing. And I get -29. Now that would be the exact same answer that you would get if you had followed PEMDAS and done the parentheses first. This is still actually following PEMDAS. We just treated the parentheses like we couldn't do it. So, and we'll see those situations when we get into variable work. So take a second and be careful. This is there is a trap door here. Look at the example and determine which of these correctly shows the distribution. Paying attention that this is negative. So take a second. Which of those correctly shows the distribution? Paying attention to the fact that that is negative. which of these, let's say A, B, or C, Mr. Walker, is the correct distribution? C. Now, how did you know that? And by the way, guys, you can always pass. When I'm using cards and I just call on you guys randomly, you can always pass. You can directly pass it off to another student. If one of your friends is like, hey, I got you, I know how to do this, you can choose who it goes to, or you can just pass, and then I just choose somebody else. So, Anthony, how'd you know that it was that one, not either of the other ones?
Because it's -6 tied to parentheses around the -1/2, and that's plus the -6, which is tied to the parentheses 1/3.
Yeah. So all of my statements start out the exact same way. It's when we get to, and I might as well just color code this, it's when we get to this part right here that you got to make sure you have the -6. We already did that, but you got to have the -6 times the 1/3.
But it becomes.
Don't make me move, you guys. That's embarrassing. What were you saying, Abby?
But it's positive.
What's positive?
1/3.
Yeah. So it's -6 times the positive 1/3. And that 1/3 doesn't have to be in parentheses. They just did it because it's a fraction. So just like we group negatives together, sometimes we group fractions together just to make it look a little nicer. Any questions on why that's the correct one?
No.
Now, sometimes we apply the distributive property just because it makes my life easier. So in this next one, in the got it, we don't have to do the distributive property, but it will make my life easier. Again, I advise you to color code this. I'm going to have a blue arrow, then I'm going to have a red. But here's the dangerous part. This minus here is a minus right now. If it's being used as a minus, it needs to continue to be used as a minus. So we're going to look at that here in just a second. The first thing I have is my blue arrow, -10 times 5.8. Then this minus says the next thing would be a minus. Then my red arrow does -10 times 6.2. That 6.2 is just 6.2 because I used this as a minus. Any questions? Because this is where people screw up. If it is a minus, it has to continue as a minus. Now we could instead make this plus -6.2. We could rewrite it and then I could use it as a negative, but that's the other option. So, do I know -10 times 5.8? Or forget about the negative for a second. What's 10 times anything? How do you do multiplication by 10? You add a 0 or move the decimal. So this becomes -58 minus, well, -10 times 6.2. Again, it's going to be a negative because negative times positive. We move this decimal and it becomes just just 62. Now minus the negative. Minus the negative here. We have a negative number minus a negative number. Hopefully it's still thinking to capture. What happens when we minus a negative, Justin?
Is it going to turn into a positive?
Yeah, this right here turns into a positive. So we can group these together. And I'm just going to keep writing down below in the next area. So this becomes -58 plus 62. Because both of these were used to make that plus. Questions? Then, do I have addition? Yes. Do I have same sign or different sign? Different. So we know we're going to have to do the difference. We first have to ask, what's my sign going to be? Positive, negative, which one's more powerful? The positive has more power. Then what's the difference between 62 and 58? Colin? 4. So we get a final answer of 4. questions? So now Fahrenheit and Celsius, or centigrade, which is the other way that we talk about Celsius. We have two different formulas. So we have, if I'm looking for Fahrenheit and I know the Celsius, I use this formula. If I'm looking for Celsius and I know the Fahrenheit, I use this formula. So here, I know the Celsius, so I plug it in right up here. So let's go ahead and embark on my first one. I'm looking for the Fahrenheit temp, so I'm going to do 9/5 times my -10 plus 32. This is easier if I make my -10 a fraction. Why do you think I say it's easier that way? Go ahead. Yeah, then I can multiply the top by the top and the bottom by the bottom. So I really get a negative number now, 90 divided by 5 plus 32. Well, 90 divided by 5 gives me 18. And I have -18 plus 32. Any questions on the math I did to this point? Who can talk me through how to add these together? I just talked through the process like 3 minutes ago. Colin?
So, which one is more powerful, 32 the positive?
Yeah, so we first identify addition with different signs. So then we do, which one's more powerful is the positive?
Positive, yep. And 32 minus 18 is 14, so the answer would be positive 14.
So a -10 degrees Celsius is actually a positive 14 degrees Fahrenheit. Now, if you heard it was 14 degrees Fahrenheit outside, you'd still probably immediately think, wow, that's really cold.
Nope.
But the weird part is that a negative of one scale is still positive of the other. Because if we looked at a thermometer and we compared Fahrenheit to Celsius, if we looked at a thermometer and compared Fahrenheit to Celsius, anyone know how their scales compare? Like, so if I drew, let's say, here's my thermometer, and here's freezing, say freezing point. Where is that for Fahrenheit? Easy, we use this all the time. Freezing point is 32. And we'll call this side the Fahrenheit side and this side the Celsius. So degrees Fahrenheit, degrees Celsius. Now what is freezing for Celsius? And this is why I am a huge fan of the metric system. Abby?
It's always confusing. Celsius is like the opposite.
Well, don't even think of it as opposite. It's just different. Anthony?
Isn't it 0?
It's 0.
That's what it is.
Then this is where you're probably, if you're like me, going to get angry.
Exactly.
What is boiling? When does water boil? Fahrenheit. Xavier?
240.
Ooh, close.
Wait.
Casey?
220?
Ooh, close.
I know this.
Hayden?
More. Izzy. I got this. I don't get last year.
If you think you know it, say it.
212.
212. It's 212.
Fahrenheit.
What is it? Anybody that knows it, what is it in Celsius?
9. I don't know what it is, but I'm guessing
12?
9. I don't know.
Oh,
9. Like 9.
So, hold up. We have the option. Let's say that we get to choose. We have the option of using a scale that freezes at positive 32 and boils at positive 212. There's some awkward distance between these. There's really 180 degrees between them. or a scale that freezes at 0, like water stops moving at 0, and then at 100 degrees, it turns from liquid into gas, or vapor. This makes absolutely more sense than does the Fahrenheit scale. Now, what could be a benefit of using Fahrenheit? If there's 180 degrees over here in this scale, between boiling and freezing, and there's 100 degrees over here in this scale, what could be a benefit? Yeah?
I just want to say something. 100 degrees Celsius, isn't it 90 degrees Celsius?
No. Boiling is 100. Trust me on this. So the benefit, and then we got to move on. The benefit, the only benefit of Fahrenheit, it's a little bit more accurate. Because there's more temperatures here, each degree change is a smaller distance. So going from 52 to 53 is a smaller distance, is more accurate than 52 to 53 on the Celsius scale is a lot bigger of a jump. And guys, if it was 52 degrees outside Celsius, you would be like vaporized. That'd be over 100 degrees Fahrenheit. So it will not vaporize, but you'd be very, very hot.
Vaporized, hot, scared me.
If it was 100 degrees Celsius outside, then you'd probably be like vaporized because your blood would boil. And boiling blood is not a good thing. It's just math. All right, so we got to do this with negative 40. Hey, take a minute. Hey, guys, take a minute. Solve out for negative 40. I'm going to do it up here, but you look at your paper. You do it down there. Don't look up here unless you're a cheater. We should not be talking. This takes you, your brain, maybe a calculator if you are going to not use your brain. Raise your hand once you blow your mind. Sorry, district policy. So Shane has already blown his mind. So much so that he's worked ahead. Shane, can you tell me what you got for your answer here? Negative 40. Now wait, we just said that the temperatures in Celsius and Fahrenheit are different from each other. There's an old saying that even a broken clock is right twice a day. Just think about it, even if the time is... So, even two different scales of numbers will match up at two places. So this is one of the places where Celsius and Fahrenheit are the same. There's one other location where Celsius and Fahrenheit temperatures are the same, and it's a positive degrees. So there are two places on their scales that they will be the same temperature and actually the same degree measure. So try this one, except this one now, we can do parentheses first because we have like terms. Do you already have it done?
No.
Oh, you have a question?
Yeah.
What's up?
Why was it negative 40?
Because negative 72 plus 32, it is a negative temperature on the Fahrenheit scale because it is so cold, it's not only below freezing, it's below zero. Like a year or two ago, we had temperatures so low, we had air temperatures that were below zero. Like, so we get Fahrenheit temperatures that are below zero. Anything Celsius below zero, you just know it's below freezing. It's not actually that cold yet. Yeah. 360 divided by 5. What's confusing you? What? You have to multiply before you add. You have to follow order of operations. Did you add before you multiplied? Were you using the correct formula? The 9/5 C plus 32?
Yeah, I did negative.
Guys, try the got it. If you haven't done it yet, you should be trying the got it. So 360 over 5. That 32 over 5 should not be over 5. And you should reduce this if possible. If you were going to put that starts as 32 over 1. So you would have had to multiply that up. So you don't have to because this does not stay in fraction form. It's not stuck. So there was minor confusion on the last problem that came out of this fraction, but that fraction, we can do that division and get an integer. So we don't work with the fraction, we get the integer and then we work with that. Because integers are better. They are our friends. What is the temperature Fahrenheit that we're plugging in here? 5, right? On your thermometer, it tells you 5 degrees Fahrenheit. So we plug in 5 inside my parentheses, and we follow the order of operations. So 5 minus 32. This is why we did that addition and subtraction of negatives, positives, that work. If I take 32 away from 5, I'm going to go past 0. So if I was you, I would think of this as 5 plus a negative 32. Take minus a positive, make it plus a negative, and then I say, okay, my negative is going to win. It's got more of a value, and then the difference between them is 27. So this becomes 5/9 times a negative 27. I'm going to put that over a 1. Now here, and we could have done this on the last problem. I'm surprised nobody suggested it. This is an option. You do not have to do it. If you choose to. Anyone know what I'm about to suggest? We can simplify through cross-reducing. You do not have to do this. But I do not want to multiply 5 times 27. I think that's too big. I identify 27 and 9 share common factors. And remember, what I do to top, I have to do to bottom. I can do anything I want to the top as long as I do it to the bottom. So I could divide 9 by 9 as long as I divide something up here by 9. So if I divide 9 by 9, I get 1. And if I divide negative 27 by 9, I get negative 3. So that really becomes 5 times negative 3 equals negative 15. My denominator is 1, and I just get my answer of negative 15. Now, the other way that we would have done that is if we did not cross-reduce. If we did not cross-reduce, I would have gotten negative 135 divided by 9. And I believe that would still come out to be negative 15. So either way, this is if I cross-reduced. This is if I didn't cross-reduce, I'd still get the same answer. So we get negative 15. So you could, if you want to, off to the other side here, say this is negative 15 degrees Celsius.
Oh, I would write like if we did like cross-reduce, this would be like.
So now, another vocab word that I don't think really many of us understood based off the SLOs that we had, a complex fraction. What does it mean for something to be complex?
Hard.
Sure, hard. Casey? Okay. Difficult.
Confusing.
Andrew?
Multiple steps.
Yeah, like complex often means there's multiple things going on or multiple things to do. A complex problem is normally not just a one-step problem. So a complex fraction is a fraction in a fraction. So if you want to remember this real easy, a complex fraction is just a fraction in a fraction. Fraction in a fraction. So this fraction, negative 3/4 tenths, well, that would be the worst name of a number ever. Negative 3/4 tenths. Yeah, so it's negative 3/4 out of 10. So this is very confusing to think about. What we need to identify is what's the main fraction bar, what is really a fraction? Like 3/4 or 1/2 or 2/3. What's really happening? What is a fraction mathematically? What's it doing? Andrew?
I'm pretty sure it's just a number, but split.
Okay, I agree. CJ, I think you just said this. Division. So this main fraction bar, if I was you, I would notate, is just division. So all that we actually have to do here is write this out as division. Take your vertical complex fraction and make it a horizontal division problem. So this I could really read as negative 3/4 divided by 10. And then I could rewrite it as negative 3/4 divided by 10. And if I have negative 3/4 divided by 10, who here can identify what my next step would be? Well, but do I do fraction divided by?
No, you need to make an actual fraction.
Okay, so I need to make 10 a fraction. How do I make 10 a fraction? Put it over a 1. Be careful, you said it backwards. Then I apply those 3 little words.
Keep, change, flip.
Keep, change, flip, right? Now you've grown, but this makes our life easier.
No, there was this, our teacher had this song for it.
Yeah, but you still remember it. So whatever it was, it worked.
That's why I remember it.
I have a song.
I kept it, I changed it, I flipped it. So now I get negative 3 on top, because we multiply straight through, over 40 on bottom. Can I reduce this? No. We are done. Negative 3/40, that's it. That, way easier than trying to understand whatever this was. So you just have to identify what is the main fraction bar and rewrite it as horizontal division. I call this horizontal just because I can stack my division vertically, or I can write out my my division horizontally. Any questions? Yeah, Xavier.
So will that red bar always be division?
So this bar is also division, but it's the division inside of a bigger division. So it's really identifying which part of the fraction, like, is the numerator a fraction or is the denominator a fraction? Here, the numerator, or my first number, was the fraction. If this one was the main bar, then it'd be 3 divided by 4/10. And then we'd have to write this out differently, because then it would be 3 divided by 4/10, and then that would change how the problem works. But that's the point of identifying what's the main fraction bar that tells me where the division's actually happening. Does that help? Does that make sense? So we're draining a pool. Hopefully you never have to pump water out of a house or anything like that. So let's say we're draining a pool. We're watching this pool drain, and we see that it has gone down by 3 feet. This must be a really big pump. In 2.5 minutes. So we can identify that this bar right here is our main fraction bar, or our main division bar. So I want you guys take a second, rewrite this horizontally using only fractions, no mixed numbers, no integers, using only fractions. Take it. You don't have to solve it all the way, but take a second to try to rewrite this using only fractions. Yes, they can be improper. So one thing that I identify is 2.5 minutes. I could really make that 5 halves. You can normally look for which bar is bigger. like wider. That's normally your main division bar. So this should turn into -3. I make that a fraction by putting it over 1. Divided by, I already converted my mixed number into an improper 5/2. We then will apply our keep change flip. -3 over 1 multiply by 2/5. I get -6 over 5, which I can leave it here, or I can convert back into a mixed -1 and 1/5. Any questions on this? I don't know what you did. Make sure that you flip the second fraction. Check your setup.
Oh yeah, 3. If it's still a -3, it will be 1. Do I put 5? You would flip 5.
So that tells me that every minute, because this is really in feet per minute, so every minute it's draining, it's going down by over a foot.
You can add another fraction.
What?
You can add another fraction on top.
What do you mean add another fraction on top?
It's like 15 halves and 5/6 over that.
What? This?
No, down. Next.
This? Oh, yeah. Sorry, you're getting ahead of me, and I thought you had questions on the one we just did. So, Justin's getting ahead of us. What's the simplified form of this complex fraction? How do I know which of these bars is my main bar? I only have one option. I can't have a 3-pieced fraction. So, I have a fraction on top, a fraction on bottom. This bar right here has to be my division. So, rewrite this horizontally. Do not skip steps. This is where people make mistakes when they start skipping steps. Do not skip steps. When I have fraction divided by fraction, those 3 words, fraction divided fraction, tell me to use my other 3 words, keep, change, flip. Jack, can you talk me through the rest of this? Atticus, can you talk me through the rest of this? So I just wrote KCF up on the board. What's that tell me to do? Keep, change, flip. So what do I do? Talk me through that process. You might know what the words mean, but tell me what to do. I can't, sorry. Surface, you're blocking. Okay, so it's concerning. So if you gentlemen both had to pass because you both don't know what's going on because you're sitting there talking to each other, identify that and move yourselves. I don't want to have to move you. That's embarrassing. Jaheim. Keep the first fraction. What's the... Yeah, change the division into multiplication. Flip that second fraction. Make sure you're getting this written down, gentlemen, because if you didn't know what to do, that tells me you haven't been doing it. Straight through, straight through. I get -10 over 6 times 15?
90.
90.
Ooh.
What's real easy about what I can do with this, Shane? I agree exactly with what you said. The other thing we can think of is if zeros are stacked, you can chop them off. And I get -1, 9. So this ridiculously complex fraction right up here just becomes -1/9.
Hey, I got it.
Woo! So you are going to have problems like this on your homework, not crazy difficult ones. Go ahead and try it. Bring questions to class with you tomorrow because 5.5 and 5.6 is one combined homework. Do not feel like you have to submit it. Notice it's due the 15th. So it's not due tomorrow. It's not due Wednesday. It's due Thursday the 15th.
Look, that color.